Hey everybody, this is Larry. This is day 15 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get started on today's problem. Non-overlapping intervals. Given a collection of intervals, find the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Okay. The borders touching but don't overlap. Okay. So I think for these problems, generally it's going to be greedy. And greedy is tough because you have to prove that greedy works, and then probably is, to be fair, a couple of intuitions that you can have for this problem that may feel like it's greedy, but or that is greedy, but may not be greedy in the correct way. And the only way for me to realize it, I mean, there's mathematical proofs that you can do conceptually, but the way that I've generally been able to do these is just by a lot of practice and a lot of just getting the feel of what subproblems are optimal and stuff like that. Yeah, and for this one, I do have a little bit of experience with it, and I think what I want to do is just by greedy, and the minimum number of intervals you have to remove is, well, let's say we have two. Well, hit this one, they're identical, so it doesn't matter. But let's say we have two intervals, like 1, 3, 1, 2, and 2, 3. They overlap, right? So in that case, it feels like it makes sense to always take the larger interval. And yeah, I think that's maybe good enough for us to get started. I think we want to sort by the endpoint. So there's definitely some sorting. We want to sort by the endpoint, and then we want to move it. We want to remove intervals one at a time as a result. So yeah, okay, let's get started. Sort key is equal to and then now for start and in intervals. So we have to keep track of in this case what do we want, right? So effectively we sort by the y interval, and then let's also sort by the, because given two segments or two intervals with the same n interval, we want to get the one that's earliest and then remove that one, right? So okay, so let's keep track of that for a little bit. Yeah, let's just have a count 0, 0. Let's see. Let's say latest is equal to 0. Are there any? I'm just looking to see if there are any negative constraints, or constraints of negative numbers. I guess it could be. So let's do negative infinity or just negative big number. Okay. If or earliest maybe is equal to also. Okay. Trying to think. I'm trying to right now. I'm trying to articulate what is in my head into consistent coding, and that's the implementation part, which is obviously a little bit tricky for me right now. So basically, and what I usually do is also just have like a little bit of an example so that I could kind of walk through it in my mind. So right now we have something like, oh, I just printed it out actually. No, I think this is. Right, and as we go from left to right, we have this array, and So now we have 1 to 1 2. Okay, so that's the interval that we're keeping. And then what happens when we get 1 3? Well, we definitely want to remove 1 3 because it can only interact with more. And then when we get to 2 3, well, we don't have to worry anymore. So then the latest would be, yeah, okay. So latest is equal to n, or max of latest n. Maybe we don't have to f earliest. Well, let's check that first. If this start is less than the previous I guess less than strictly the previous latest, that means that we have to remove this thing, and then after that we just keep track of the latest that way, and maybe that's it. I'm trying to think of it. Okay, well, maybe that's not it. Because then now the latest is equal to 3. Now this is not right, that's why. So we only want to, because this gets removed, right? So this is an else. Okay. Okay, let's try a couple more. I think, to be honest, I think this is one of those problems where the code is easy if you're really able to articulate what you want to do. But as you can see, even though this is like 10 lines of code, I'm struggling a little bit. And usually I would, and I'm going to do some like really basic, examples. But I think what I want to do is just probably going to submit, because just to get more test cases, just for time purposes. Because I'm still not confident about this one, and it is accepted actually, so that's actually a little bit surprising, to be honest. But that's the problem with these greedy problems, is that for me, you really have to have the experience to kind of, play around with it. And to be frank, even with that experience, sometimes you're going to be wrong, and you just have to put your code in a way such that you're able to adapt to different things being, like, you have to adapt to be like, okay, so this is wrong for this test case, how can I debug this test case as best as possible? And that's kind of the way that I would think about it. I do feel like I'm a little bit lucky on this particular problem, in that I did get accepted first time. I actually didn't expect that, as I mentioned. So yeah, so I guess the naive greedy works. I think for me it's just okay, having two intervals, we always want to remove the one that is longer, and then yeah, and you kind of go through my thought process as I discover one at a time. But yeah, that's why for this problem. Let me know what you think, and I'll see y'all tomorrow. Bye bye.